Hello friends, here in this video we will see the design procedure for turnbuckle. For that purpose here I have drawn the diagram. In this diagram as we can see this is a turnbuckle. Now when I look into this, here the important parts are these which I have shown in blue section. These are screw threads. These are the screw threads which are used in case of turnbuckle. As we can see on the left hand side I have left hand threaded rod. On the right hand side it is right hand threaded rod. Both of the screw threads, they are in a coupler nut as I have written here, because since we have screw must also have nut so that they can assemble. So here I have screw as well as nut which is called as the coupler nut. Then there is the middle portion which is called as the coupler. Next, here I have small d as the diameter of this square threaded, or we can say this is a screw. Next, capital D is the diameter of coupler nut. Then D1 is the internal diameter of coupler and D2 is the external diameter of coupler. Now see turnbuckle, where it is used, I'll explain. See turnbuckle mostly we can see in case of railways. Here I will draw a simple diagram. Here there is an electric pole at the railway and this is the steel cable which we want to be in tension always, because if this steel cable will somewhat sag or if it will hang, it means if it is not very tight, then the transmission won't be proper. So for that purpose here we have a device called as turnbuckle, with the help of which if we rotate the turnbuckle we can adjust the tension in this cable, and so it is used to either loosen or to tighten this cable. Next, if we look at the coupler nut, it would be looking like this. That if I can give the example of a complete turnbuckle in 3D, it would be looking something like this. Here I am drawing the diagram for a turnbuckle. This is a hexagonal nut. Now this is a diagram of a turnbuckle, how it looks in 3D. Now this is the left hand threaded portion and here I have the right hand threaded portion. These are screw which are there on both the sides. Now if we want to operate this turnbuckle, we need to rotate this nut which is here. If I rotate this, then either both of the threads, they would be coming in or they will be moving away. That is, just by rotating the nut in one direction we can get the two motion of the screw, either they can come inside or they can move out. So just by giving a single rotation we can get the motion of the screw. Now after we have understood about the coupler nut, or we can say the entire turnbuckle, we can start with its design procedure. So here we have the complete design procedure for turnbuckle. When we are designing turnbuckle, it is also called as adjustable screwed joint. That is the other name for turnbuckle. Now, see, when we are designing this, in that case, we should remember that in a turnbuckle, there are three main components which need to be designed, and that is the screw, which are both the left hand thread and the right hand thread that we have to design. Next, we should design the coupler nut, and third, we should design the coupler. So in total, we have three components which we need to design, that is left hand thread, right hand thread, they are same, we can design the same dimensions for them. Then there is coupler nut and coupler. So three main parts to be designed. Now, when the load is applied, here I am showing that tensile load is applied. Turnbuckle can even be used for compressive load. It means the load can even act inwards. So in both the applications, turnbuckle is used. Now, see, before starting any of the design, we need to know which will be the weakest section, or failure will start at which section first, that we should remember. So if I look at this turnbuckle, here I am having screw threads. So in screw threads, as we know, the area is not uniform. Somewhere we are getting maximum area and at some point we get minimum area. So failure will always start at minimum area, and that is for the screw thread. So the first thing that we will design, it will be the screw thread. So let us start with step number 1. Step number 1, we have design of screw rod. Now, see, when we look at a screw, I'll just draw the profile here to explain that screw looks something like this. That is, it has the minimum diameter and maximum diameter. So this diagram I have drawn, it is a screw, just a profile of the thread. Now, as we can see in this diagram, here I have two different set of diameters. This is the minimum diameter called as D suffix C, that is core diameter, and then I have this outer diameter which is called as the nominal diameter or major diameter. So now, when you have two different values of diameters, failure will always start at the minimum diameter, and as I see in this diagram, DC is less than DO. So while designing, we will be considering core diameter, that is the minimum diameter. So here I'll say that, first of all, considering failure of screw thread or screw threaded, or we can say threaded screw rod, considering failure of screw threaded rod under tension. Now if I consider the tensile failure, then we should know the resisting area. So considering failure of screw threaded rod under tension, for that I will draw the diagram of the failing area. Now this is the area which fails, and here I am marking DC, that is the core diameter. See why I am taking core diameter, because screw thread, it will fail along this core diameter because this is the minimum diameter, and hence it will give us minimum area, and failure always starts from minimum area. So here this is the failing area, and I'll say that therefore resisting area capital A, it will be equal to pi by 4 into DC square. So hence I'll say that therefore we are considering failure under tension. So tensile strength of rod, that we can write it as P is equal to, since we are considering tensile strength, so therefore your load will be equal to tensile stress into area. So therefore P is equal to, area is pi by 4 dc square multiplied by sigma t. So this is equation number 1. Now we can say that from equation number 1, if we know the value of load, if we know sigma t tensile stress, we can easily calculate the core diameter for this screw. So I'll say that therefore from equation number 1, dc, that is the core diameter of screw thread, can be calculated. Now once I know DC, I can even calculate this DO, which is the outer diameter of screw thread. So next I'll say that therefore outer diameter is called as major diameter or it is called as nominal diameter of screw thread, that is DO, D suffix O, the nominal diameter, it is core diameter DC divided by 0.84. So we can use this empirical relation to calculate nominal diameter of screw thread. Now this is the completion of step number 1. In that we have designed the screw thread for turnbuckle. Now the second component that we will design in it is, it will be this coupler nut which holds the screw. Now for designing of coupler nut, we will be taking 3 cases. First I'll consider tensile failure, then shear failure, and then crushing failure for this coupler nut. So let us get started with its design. Step number 2 is design of coupler nut. In this, the first step is considering tensile failure of coupler nut. Now when I am considering tensile failure, see here I have the diagram of the coupler nut. This coupler nut, it can break. Here I can show it even on the 3D diagram. This is the coupler nut. This can break into 2 halves like this. When the load is applied, in that case this coupler nut can break into 2 parts, and after breaking, what it looks like, that I will draw. So here I have the failing diagram, or you can say failing area of the coupler nut. Now here I have capital D, it is the outer diameter of coupler nut, and this inner diameter will be DO, because for a nut the minimum diameter is the major diameter, that we have to remember. Now considering tensile failure of coupler nut, this is the resisting area. I'll say that therefore resisting area, it is pi by 4 capital D square minus DO square. Next, when I am considering the tensile failure, I will say that therefore tensile strength of coupler nut, I will write it onto the next page. Since we are considering tensile strength, strength means the load carrying capacity. So it is the load which is equal to tensile stress into area. So therefore P is equal to, the area is pi by 4 capital D square minus dO square into sigma T. So here is equation number 2. So we can say that from equation number 2 we can calculate the outer diameter of coupler nut. So therefore from equation number 2, the outer diameter of coupler nut, that is capital D, it can be calculated. Now this was by considering tensile failure of coupler nut. Now we will consider shear failure of coupler nut. So in step number 2 itself, that is the design of coupler nut. In this we are considering shearing failure of coupler nut. Now when I consider shear failure, I can explain here that suppose I'll take an example that when the load is applied, if it is towards right or it can even be towards left, I am taking this one example. If it is towards right, then this screw thread here, it can move forward by breaking the threads here. It means the threads of the coupler nut will break like this once the screw thread goes forward. So this action is called as shearing. So now I'll say that therefore resisting area is given by capital A is equal to pi into DC multiplied by L. Now what is this pi into DC? I'll explain with a diagram. That here I have a screw thread. So now I am drawing the thread profile here. This is a screw thread which I am drawing. Now how it will shear is that when the load is applied, suppose for example if it is towards right, then this screw thread is in contact with the nut, or we can say coupler nut. It is in contact with the coupler nut as I have shown here. So this coupler nut, when the screw thread moves forward, there are chances of the nuts breaking at its teeth, that is these threads, they can shear off, they can break when the screw thread moves forward. So the resisting area is pi DC into the length of this coupler nut. So here the area is pi DC, that is the circumference multiplied by length, where I'll say that let small l be equal to the length of coupler nut. Now once I have got the area, since I am considering shearing, I can write down shearing strength of coupler nut. So therefore shearing strength of coupler nut, that is P is equal to, since we are considering shearing, therefore it will be shear stress multiplied by area. So hence shearing strength becomes, area is pi DC into L multiplied by shear stress. So this is equation number 3, and I can say that therefore from equation number 3, this length of coupler nut, which is small l, can be calculated. Now we have seen the shearing of coupler nut. After that we will see the crushing of this. So I'll say that again in step number 2, that is the design of coupler nut. In this, now I'll consider the third kind of failure, which is considering crushing failure of coupler nut. Now, when we are considering crushing failure, then in that case, I can say that if I draw the failure diagram, then I will be able to explain it in a better manner. Now, here I have DO as the nominal diameter and DC as the core diameter. See, crushing will take place at this outer periphery. This is the region which will crush. Now, how this crushing takes place? As I have explained this diagram, this was in case of shear. Now, instead of shearing, these screw threads, they are in contact with the nut. So, instead of shearing, they can even crush like this. They can just crush. So, crushing means it is called as local compression, that is irrespective of the load which is outside. At the contact, the two members of a machine, they must crush. So, here the screw and nut, they are crushing, and when they are crushing, some small metal powders are formed, and in that case we can say that this coupler nut and screw, they are failing. So, now the crushing area is only the outer periphery. So, here I can write down, therefore, resisting area capital A is equal to pi by 4 outer diameter square, which is DO square minus DC square. Next, after getting this resisting area, now I can find the crushing strength of coupler nut. So, therefore, crushing strength of coupler nut. Strength means load. Since we are interested in finding the crushing strength, so here I have P is equal to crushing stress multiplied by area. So, therefore, P is equal to area is pi by 4 DO square minus DC square. Now, in this I will multiply by n, small n, into small l into sigma CR. I will explain what are these terms. This will be equation number 4 for us. Here I will say that let small n is equal to number of threads in contact per mm length. So, here I am denoting a term small n. It indicates the number of threads which are in contact for 1 mm length, that is the contact between screw and nut, and small l is nothing but length of coupler nut. So, I can say that from this equation number 4, sigma CR can be checked, or if sigma CR is known, then we can get n, that is the number of threads in contact per mm length, it can be calculated. So, this completes our step number 2, that is design of coupler nut. Now, the only last part which is left in this design, and that is the design of this coupler which joins the left hand and right hand portion. Now, this coupler, as we can see, it is hollow from inside. This D1 indicates the internal diameter, D2 is the external diameter. So, we can say that when the load is applied, if I am considering the load to be in tension, tensile load, in that case this coupler, it can break into two halves like this, it can split. So coupler we will design by considering tensile failure. So our step number 3 is, step 3, it is design of coupler. Now in design of coupler, I'll say considering tensile failure of coupler. Now I'll draw the failing area. Coupler is circular in section. It has outer diameter capital D2. Its inner diameter is D1, and this is the failing area. So I can say that here, so therefore resisting area capital A, it will be equal to pi by 4 D2 square minus D1 square, since it is hollow portion. So I'll say that therefore tensile strength of coupler, it will be given by, since we are finding strength, strength means load, and it is tensile strength, so therefore P is equal to tensile stress into area. So hence this P is equal to, area is pi by 4 D2 square minus D1 square into tensile stress. So this is equation number 5 for us. So we can say that therefore from equation number 5, D2 can be calculated, but for that we should know D1, and D1 can be fixed by using some empirical relation. That empirical relation I am giving, it is DO plus, we can take it as around 6 mm. So in DO, if we add 6 mm, that becomes the inner diameter of coupler, and from that if we know all the values, we can find D2, that is the outer diameter of coupler. So here was the turnbuckle, which consisted of left hand screw thread, right hand screw thread, coupler nut and coupler, and we have completely designed it first by taking the step number 1 as design of screw. Then we had seen the design of coupler nut by considering 3 kinds of failure: tensile, shear and crushing, and at last we have designed in step number 3 this coupler considering tensile failure. So this video shows the design procedure of turnbuckle.